Hello, dear students. This is Ashish Sharma, and this is your lecture 16 of second unit. In lecture 15, we discussed about horizontal projectile. How can we calculate the horizontal range and velocity when projectiles strike the ground? Dear students, as I discussed with you, horizontal projectile or any projectile is combination of uniform motion and non-uniform motion. Horizontal motion is uniform motion while vertical motion is non-uniform motion. So now moving ahead one step, now we are having angular projectile. An angular projectile is an object which has given some initial velocity at some angle from the horizontal direction. Then it has velocity u. It has two components: horizontal component u cos theta, vertical component u sin theta. The maximum height achieved by it h, and the maximum range where it will touch the ground is r. In this derivation we will study how to calculate these three vital parameters of a projectile. For calculating time of maximum height or time of flight, let me tell you one thing. The vertical initial velocity is u sine theta, and when the projectile is on the peak, the vertical velocity becomes 0, and then it starts then vertical velocity changes its direction and starts increasing in downward direction. Acceleration due to gravity when projectile is going up is always downward, and it is equal to g. So if we considering upward direction positive, the acceleration due to gravity is going to be negative downwards. Putting these values in equation, v is equal to u plus at, final velocity is 0, initial velocity is u sine theta, acceleration is minus g, and t is the time in which projectile will reach the maximum height. So t is equal to u sine theta by g. Dear students, we know that the time taken by an object in reaching some height is always equal to time taken by object in coming back from that height. So if half of the journey is traveled in t time, then full journey is traveled in t plus t 2t time. So time of flight is 2u sine theta by g. Now when I am having time, I can apply v square minus u square is equal to 2as for calculating the height. We know that final velocity is 0 at maximum height, initial velocity is u sine theta, that is vertical velocity, and acceleration is minus g. Putting these values, we can calculate h is equal to u square sine square theta by 2g, that is the maximum height. So maximum height we have calculated. Next is horizontal range. So as you were observing that in vertical motion we have applied the equations of motion, because vertical motion is non-uniform motion but the horizontal motion is uniform motion. So we will apply simple formula: distance is equal to speed into time. We know that horizontal speed is u cos theta and it will remain constant, and time of flight we just calculated 2 u sine theta by g. Putting the values in this equation and applying the formula, 2 sine theta cos theta is equal to sine 2 theta, range came out to be u square sine 2 theta by g. Maximum range of a projectile. So it is obvious from this formula that range will be maximum if sine 2 theta is maximum, and sine 2 theta is going to be maximum if sine 2 theta is equal to 1, or 2 theta is equal to 90 degree, or theta is equal to 45 degree. So range of a projectile is maximum at 45 degree. Let us understand with the help of an example. Find the angle of projection for a body to have same horizontal range and maximum height. So we know the formula of horizontal range and we know the formula of maximum height. If we compare these formulas and cut out the common terms, we are left with 2 sine theta cos theta is equal to sine square theta. 1 sine theta will cancel out again, and tangent theta is equal to 4, or theta is equal to tangent inverse 4. So this is how we calculate or solve numericals. Two angles for same horizontal range. If we project the projectile at an angle theta or at an angle 90 minus theta, it will always have same range. We can show it very easily. In one range formula we had taken theta, and in other formula we had taken 90 minus theta in place of theta. And solving, we found that left hand side is equal to right hand side, because as sine 180 minus theta is equal to sine theta, so sine 180 minus 2 theta is going to be sine 2 theta. So we can conclude that theta and 90 minus theta angle of the projection results in the same horizontal range. Next is projectile fire at an angle with the vertical. So previous derivation we have done using angle of projection with the horizontal. If the projectile is projected with the vertical, the angle with the if the projectile is projected with the vertical making angle theta, then obviously the angle with the horizontal will become 90 minus theta. So if we are to calculate the equations for a projectile projected with vertical angle, we can simply put the value of theta, which is given with the vertical, in the formulae we have derived for horizontal, but with small change by putting 90 minus theta in place of theta, and those formulae will give me the relations for projectile fired at an angle of theta with the vertical. So is it quite simple? Let me tell you, like we have derived the relations for this theta. If we are to calculate relations for this theta, so we know that our original theta is now 90 minus theta. So in our original formulas, if we put 90 minus theta, we can have all the relations. So putting 90 minus theta in place of theta, we can get the relations for the vertical and projectile with the vertical angle. One more thing, the equation of path of projectile is y is equal to x tan theta minus half gx square divided by u square cos square theta. For calculating path of projectile with the vertical, we place 90 minus theta in place of theta and we'll get the relation. The next is angular displacement. Angular displacement is the angle covered by an object when it is moving in a circular motion. Suppose an object started from P and reaching on Q. Doing so, it has covered theta angle. Then angular displacement is represented by theta, and it is generally represented in radian. Radian is the standard unit, SI unit of angle, and angle in radian is equal to arc divided by radius of circle. Next is angular velocity. The rate at which this angle is covered is known as angular velocity. It is represented by omega. It is the rate of change of angular displacement. So its unit becomes radian per second. We can also represent it like if theta has been changed from theta 1 to theta 2. So change in angle will become theta 2 minus theta 1 divided by time taken, that is t2 minus t1. So it is similar to linear velocity, where linear velocity is your change in displacement by time taken. Your angular velocity is a change in angular displacement divided by time taken, or angular velocity omega is equal to d theta by dt. Angular velocity is a vector quantity. So if the object is moving in anti-clockwise direction, and if we imagine our right hand placed on this circle and we rotate it anti-clockwise, our thumb will point in upward direction. So the direction of omega is going to be perpendicular upward. While if the object is moving in clockwise manner from P to Q, and we place our right hand here and curve our fingers in clockwise directions, then our thumb will point in downward direction, and that is going to be the direction of omega for clockwise motion. So with this, revise the derivations in writing and do the numericals. I have also shared the pages of book in which solved examples are there and questions are there. That is your homework. We'll see you in next lecture. In next lecture we will study about angular acceleration and equations of motion, how do we apply them on circular motion, and that is the end of this chapter. We'll see you in next lecture. Thank you.